Okay, so answer for the homework, page 27B, this diagram right here, this is the solution. So final answer is 8,635. The trick to this question is because you want part of the surface area, but you don't want part of the surface area. And so that's why you had to subtract the circles, but then add on the lateral surface. So that's the tricky part. If you just did the circumference formula of the big cylinder, subtract the small cylinder, you're not going to get to the correct answer. So I would say easiest way to do this is to actually open it up, open up the cylinder, and then you can see what you need and what you don't need. Okay. So this is an example of a composite figure question involving volume, surface area. I would say if you see something like this on the test, it will be one of the hardest one. Okay, if you can do this, then good job. Okay, then you should have no problem on the test. Okay, one last thing I want to go over is this figure right here. What shapes do you see? For number 8. Number 8, what shapes do you see? Brian? Sorry, not Brian. Ready? All right. Half a cylinder and a rectangular prism. That's right. Yesterday when somebody said they see a circle and a rectangle. Well, remember, circle, rectangle, triangle, these are only 2D shapes. In this 3D shape, the 3D shapes of it is cylinder and rectangular prism. All right, so make sure you're using the right words, right shape, looking at the right shape, and not just the 2D figure, but the whole thing. All right, so let's move on to today's page 21. Page 21. This one. Okay. Page 21. Where did you find her? It was the outdoor classroom. I think it was only important. Oh, okay. Bye. Okay. Okay, so we found the volume of A, volume of B, volume of C, and you can see that volume of B is twice as big as volume of A because the height is double. And then if you compare the volume of C with volume of A, it's 4 times as big. And that's because, looking at the formula, radius square. So when you double the radius, 2 to the power of 2 gives you 4, so that's why it's 4 times as big. Okay. I just added in this question, draw 3 rectangles with a perimeter of 40, and then figure out which one has the greatest area. So, Jayan, if I have a perimeter of 40 meters, can you tell me the dimension of one rectangle? I have 40 meters. Okay, so I have 40 meters. Can you tell me the dimension of one rectangle? Alright, so like what plus what plus what plus what gives me 40? Okay, Hiroki, you want to help him? Alright, then let's make sure we both pay attention, right? 15 and 5, good. Alright, so 15, 15, 5, and 5. Okay, that would add up to a perimeter of 40. All right, what's the area of this rectangle? 15 times 5. Who's good at mental math? Oh, that's a little too much. 75, right. Good mental math there. 75 meters squared. All right, somebody give me another one. Jayan, you want to give me another one now, or you want to pay attention? Oh. All right. Another rectangle. So Brian came up with one. 15 plus 5 plus 15 plus 5. Okay, I'll come back to you. Stefan, give me the next one. 13 and 7. Good. Okay. There's tons. So 13 by 7. 13 plus 7 plus 13 plus 7. What's the area of this one? 13 times 7. Yep. Oh, okay. 91. Okay, how about now? Okay, Jayan, did you figure out what? Okay, Frank, you want to help him? Huh? 12.8, okay. Who has another one? 11.9. Which one? Oh, 11.9. All right. I'm looking for one in particular. 6 and 14, okay, but I'm still looking for one. 18 and 2. Okay. Yeah, all those are good. 10 by 10. That's right. Is a square a rectangle? Yes, but a rectangle is not a square. Okay. 10 plus 10 plus 10 plus 10. And so area 100. Okay. Out of these three, which one has the biggest area? The square. Okay. And in fact, it works for every time. It works every time. So whenever you want minimum perimeter or maximum area, a square will always give you that answer. Okay. Okay. So for example, next time, let's say I give you a perimeter of 20 meters. Then I know that a square. If I draw a square, I'll know the area right away. I won't have to draw like 10 different rectangles. What's the 3D shape of a square? Cube. Cube. Right. So same idea. A cube will give you the biggest volume. Okay, and minimum surface area. Okay, this is called optimization. I've seen this question come up in EQAO before. Okay, last one, last question. So I have a cone inside a cylinder. Okay, radius is 5, height is 10, and I'm looking for the space in between these two shapes. Okay, what's your plan, Carson? I'm looking for space, so. Stefan? So you gotta find the cylinder, and then you gotta subtract the volume of what? Subtract. Right, good. So find the volume of the cylinder first. What's the formula? Pi r square height. Pi r square height. Good. All right, so 3.14 times Rashawn, what's my radius? You have it in front of you. 5. Yeah, page 21. 5 square. 5 centimeters. Yeah. Good. Okay, don't forget the square because that's part of the formula. And then Carson, what's height? 10. Yeah. So substituting the numbers in, you get 785 centimeter cube. Okay, volume of a cone. Okay, what's the formula for volume of a cone? Volume of a cone formula. Good job. Pi r square height divided by 3. What do you notice about these two? What's the relation between them?
The same radius.
And the same height. So what do I just have to do? So what? Okay, Jerry?
Divide 785 by 3.
Yeah, that's all I have to do because everything is the same. So just divide by 3. 785 divided by 3, 261. About 261.6 centimeter cube. Okay. So what's my final answer then? What did we say we have to do? Subtract them. Good. Not add, but subtract because I want the space in between them. Okay, and I get about roughly about 523 centimeter cube. Okay. So what do we say the connection is between a cone and a cylinder? Given the height and radius is the same, what's the connection with their volume?
All you gotta do is divide by 3.
All you have to do is divide by 3. So let's say I have a paper cup of water. All right. You know those cone-shaped cups that you guys get at the doctor's office? Yeah, those cone paper cups. So let's say you fill it with water. All right. How many of those will it take to fill up that cylinder? That's of the same size. Huh?
1 and a bit.
1 and a bit. I'm looking. Or 1 or 2 or 3. That's right, because it says in your formula that is it takes 3. Okay. EQAO asks this question every year between the cone and a cylinder. However, last year they tried to trick people. All right. Last year's question was, let's say you have that cylinder full of water and you pour it into the cone. How much water is left in the cylinder?
About 1 drop, like 2.
2/3. 2/3. Alright, so you have a cone, you have a cylinder, you pour it in, it's 1/3, but they're asking how much is left in the cylinder, which is 2/3. Alright, so they try to trick you guys with this type of question. If that didn't make sense, here, let me draw that picture for you. Okay, so this is full of water, and then I poured 1/3 of it in the cone, and so how much is left in here? 2/3 is left in the cylinder. All right, so yeah, so I know that you guys understand the question, but sometimes EQAO likes to do this to trick you guys with the wording. So looking at the formula sheet, what's the connection between rectangular prism and a triangular prism for volume? It's half, right? That's right. So triangular prism and rectangular prism, it's half. Right? What about a cube and a square pyramid?
Same radius.
There's no radius in a triangle. Yeah. By 3, right? So it takes 3 square base pyramid to make 1 cube. Okay. Okay. Last trick question. What is the connection between the surface area of cylinder and cone?
You're not me, bro. Is it half times? No, it's 1/3. Is it 2 times? 1/3.
So, Mingyu, how about you? What's the connection between surface area of a cone and a cylinder?
1/3.
Okay, some says a third, some says half, some says pi. Sean, what about you? What do you think? Any relation between the surface area of a cone and a cylinder?
Oh, you can't hang this time.
Don't ask Google.
Totally not.
The relation's not really clear. It's just one common side.
Uh-huh. So is there a relation?
Yes.
So remember I said it's a tricky question? So there's no connection for any of these surface area. All right. The only questions you'll see on EQAO is connections in volume. All right. So that's why I said it's a tricky question. All right. So you're either comparing the volume of a cone with a cylinder, or you're comparing the volume of a cube with a prism or a pyramid. So all you're doing is comparing volume. There's no connection for surface area. Okay, so don't get tricked. That's why in this example right here, we were just comparing volume as well. Okay, so that's it. Homework for tonight, page 22 and 23. Those two pages. Answers are on page 24 for you guys to check.
Oh, thank you.
You're welcome. And then tomorrow we'll do we'll start the review. Okay?